Hello everyone, welcome back to the channel. I hope you guys are doing extremely well. In today's video, we'll be discussing about a LeetCode medium problem, find triangular sum of an array. Although this is a medium problem, it is quite simple and it is that of the level of an easy problem. So in this video, we'll be discussing two approaches to this one particular problem. One is the naive approach, and another one is the optimized approach. So let's quickly get started. So I hope my screen is visible, the phone screen. So let's read the question. You are given zero indexed array nums, where nums of I is a digit between 0 and 1, inclusive of the numbers. Um, the triangular sum of nums is the value of the only element present in nums after the following process terminates. Let nums comprise of n elements. If n is equal to 1, end the process. Otherwise, create a new zero indexed integer array, new nums of the length n minus 1. For each index I, where 0 lesser than equal to I lesser than n minus 1, assign the value of new of I nums as nums of I plus nums of I plus 1 modulo 10, where modulus denotes the modulo operator. Replace the array nums with new nums. Repeat the entire process from step 1. Return the sum of the nums. So let's see the first example. In the first example, it's given that the original array is 1, 2, 2, 3, 4. When you add 1 and 2, you get 3. When you add 2 and 3, you get 5. When you add 3 and 4, you get 7. When you add 4 and 5, you get 9. When you add 3 and 5, you get 8. When you add 5 and 7, you get 2. When you add 7 and 9, you get 6. And in the third step, 8 plus 2 is 10. But if you take modulus of 10, it's again 0. 2 plus 6 is 8. It's 10. Sorry, it's 8. 0 plus 8 is again 8. And the answer is 8 as depicted in the diagram. So we can, in the second example, it's given that there's only one element in the nums. So n is already 1. So we just written the first element. So let's quickly understand how we solve this problem. So let's try it for the first test case. 1, 2, 3, 4, and 5. So I know when I add this, I get 3. When I add this, I get 5. When I add these two numbers, I get 7. And when I add this, I get 9. 3 plus 5 is 8. 12 modulus 2 is going to be 2. 7 plus 9 is 16. Modulus 10 is going to be 6. 8 plus 2 is 10. Modulus is 0. 6 plus 2 is 8. Modulus 10 is 8. 8 plus 0 is again 8. And this is our final answer. So how do we approach this problem? So it's very clear that we need to store the previous value in order to compute the next value. So let's say I have this array as like these are the elements in my array. At the first step, I get some x, y, z value, and I need to store it somewhere. And again, at the second step, I get x, y, and I need to store this somewhere. And again, I compute x, and this is going to be my final answer. So at every step of the computation, I need to store the new values in the array in order to recompute it for obtaining the further values. So in order to do this, let's say I have the original array nums, which is 1, 2, 3, 4, 5, and I'll be running a loop till size of nums not equal to 1. So that's a stopping condition. Whenever the size of number is 1, we just terminate the loop. And what will I be doing here is I'll be creating an vector array. Let me just name it as V. array or with the name current. So this current array is going to store my current values after computing from the previous array's value. So I'll be starting a for loop. I'll be starting a for loop where I'll be running I equal to 0 till n minus 1, I less than n minus 1. And I'll be summing up the ith value and the I plus 1th value. So current dot push back of nums of I plus nums of I plus 1. And it is clearly stated in the question that we'll be taking modulus 10 for every value we compute so that the range lies between 10. So modulus 10. So we'll be pushing nums of I plus nums of I plus 1, the whole modulus 10. And that will be stored in our current. And after this entire for loop is uh, finished, I'll be storing nums equal to current. So when I come back to this, my num size would have obviously be reduced to 4 because the size was originally 5. And now, since I'm learning my loop n minus 1, it's absolutely it's obviously it's going to be 4. So in order to understand this algorithm in depth, let's run it for a very short test case. Let's say my array only has 1, 2, 3, like 3 elements. N is going to be 3. I know one thing for sure. Whenever n is 1 or the array size num size is 1, I need to stop my loop and return the 0th index of my nums. So whenever the size of nums not equal to 1, the first step, my current array will be initialized to null or no values. I'll be running a for loop from I equal to 0 to I equal to 1. So whenever I is 0, I in my current array, I'll have 1 plus 2. Since we discussed this before, I'll be pushing nums of I plus nums of I plus 1 index modulo 10. So we know that nums of I, which is 0, the ith index is 0, so the value is 1. I plus 1, 0 plus 1 is 1. The value is 2. 1 plus 2 is 3. 3 modulus 10 is obviously 3. So current of 0th position will have 3 now. And again, I increments to 1. Now I is 1. After I is 1, my uh, current index will be pointing here. So I'll be adding 2 plus the next index 3. So it's 5. Current of 1 is going to be 5. And according to our algorithm, we'll be after this for loop gets over, we'll be storing the current value in nums, which means now our nums is the value of the values that are in the current. So our nums array becomes 3, 3 and 5. And the size of our nums array is 2. From 1 to 3, we computed 3 and 5. And since size of nums is not equal to 1, we again recompute that our current array is going to be null and start the for loop from I equal to 0 till n minus 1, that is 1. Okay, the size of array is 2, so it's 1, yeah. So I'll be at 0th index, my index will be the location will be pointing at 3. and the current of 0 is going to be 3 plus 5 modulus 10, which is 8, and that's it. The for loop gets over now. Nums will take the value of the current array, and now the size of nums is 1, that is 8. Since the size of nums is 1, this condition is false, and the loop, it comes out of the loop, and at finally we return nums of 0. So let's quickly code it up. Um, I know one thing for sure. I need a size of nums. So whenever n is not equal to 1, I declare an array current. This current is going to give me the previous values from the previous array. This current will have the new values for int I n minus 1 plus I. Um, Current dot push back of of I plus of I plus 1 modulus, and at the end I'll be putting nums value in current, sorry, current's value in nums. So instead of defining n here, I can just define size of nums because the nums keeps changing. I don't need the statement. After the while loops gets executed, I return nums of 0. Let me run it. Compilation error. Okay. N is not defined. I can just define the size of nums. Accepted. Let me submit it. Test case is passed. But you would have noticed that I'm using an extra space called current. So in an interview, if this question is asked, your first approach should be this, the naive approach, which I explained now. If the interview asks you to optimize it, in that case, what you'll do is you need to avoid that extra space current. So how do you avoid it? Let's take the same example, nums equal to 1, 2, 3. Uh, it will be as the previously explained steps, except that you wouldn't be using the current array. So same thing we'll be checking while size of nums not equal to minus 1. Instead of writing this current array, I know one thing for sure, that uh, the last element of my nums array is going to be eliminated. That is, if I'm going to compute the zeroth value of nums and one value of the first index of nums, I'll be obviously eliminating this second index because 1 plus 2 will be stored in my zeroth index. 2 plus 3 is going to be stored in my first index. So my second index is going to be discarded. In that case, I can run the same for loop. Instead of defining current, I can store this value in nums of I. So in my zeroth location, 1 plus in my zeroth location, 1 and 2 will be stored. The sum of 1 and 2 will be stored, that is 3. In my first location, 2 and 3 will be stored, that is 5. But you may have a doubt now, what about the second location? After this for loop ends, we'll be uh, popping up the last value from the array. That is, we'll be using the pop back function, which ultimately discards the value 3 from the array, and our new num now becomes 3 and 5. Similarly, again, the nums of 0 will be computed as 3 plus 5, which is 8, or yeah, which is 8. And I'll be popping the fifth value, the element 5, using nums, using the statement nums dot pop back. And in the end, I'll be returning nums of 0. So let's submit it. Compilation error. Okay, extra unwanted bracket. So it got accepted for 2 test cases. Let's try for the other test cases. It got accepted. So I hope you understood both the methods which I explained now. If you do have any doubts, please put it in the comment section so I can come and clarify it. And that's it for today. Hope happy coding.